Good evening, class. This is a Pre-Algebra lesson 3.1, solving equations by adding. So this is a really foundational lesson to solving equations. So I hope you'll pay attention. And remember, this lesson will be up on the internet maybe forever, so you can always come back to it and look at it again if you want further help. All right, grab some popcorn and your four-color pen, your notes, and let's get rolling. So solving equations by adding. All right, let's start off with a couple terms. Terms. All right, first off, what is an equation? What is an equation? Basically, when you're talking about an equation, you're just talking about a mathematical sentence that contains an equal sign. So number one, equation, a mathematical sentence that contains an equal sign. A mathematical sentence that contains an equal sign. No big deal, right? Whenever it's an equation, there's going to be an equal sign, there's going to be stuff on the left, there's going to be stuff on the right. That's the idea. Something maybe like this, right? 3x plus 2 equals 75. That would be an equation. Notice you've got that equal sign, you've got stuff on the left, you've got stuff on the right. That's an equation, a mathematical statement that contains an equal sign. Basically, the reality is it's two things that are equal. All right, well, it's important to understand the solution to an equation. What is the solution to an equation? It's the value, and by the way, I'm going to use a parentheses and an S, or values. The higher we go in our math, we'll find that some equations can have more than one solution. All right, the ones we're dealing with, mostly one, but we'll find later on. So I'm going to put an apostrophe S. The value of the variable, that makes the equation true. The value of the variable that makes the equation true. The value of the variable that makes the equation true. All right, so that's what we're talking about. That's the idea. So let me give you an example here. Here's an example of an equation. Let's do x minus 3 equals 15. X minus 3 equals 15. Now, some of you guys that are sharp, you can look at that and you should know the solution. So, solution. And hopefully you say the solution is x equals 18. And hopefully you can look at that and figure that out. All right, well, if the solution is x equals 18, then we should be able to put 18 in for the variable, right? Haven't we done substitution work already before? We have, right? We should be able to put 18 in for the variable. And when we're done, we should have a left side equaling a right side, and we do. So in other words, what's left should be true, and it is. And if it's true, then 18 was indeed the solution to the equation. 18 is indeed the solution to the equation. All right, so let's get into this aspect. What does it mean to solve an equation? We're not going to write that, but that's my question to you. What does it mean to solve an equation? So I'm going to put A, and I'm going to go to red here and write solving. What is solving? Use my implies. What is solving? All right, whenever you see that idea or you're asked, what does it mean to solve an equation? This is what you should think. Isolate the variable. Isolate the variable. That's what you should be thinking when you're told solve an equation. Isolate the variable. All right, well, what does that mean, right? So let's write a few words here. You should know what it means to isolate the variable. What does that mean? Well, let's write get the variable. Get the variable all by itself. Get the variable all by itself on one side of the equal sign. get the variable all by itself on one side of the equal sign. Get the variable all by itself on one side of the equal sign. That's what it means to solve an equation. So when you solve an equation, it'll look something like this. N equals 13. All right. Notice the n is all by itself. It's on the left-hand side of the equal sign, and the 13 is on the right. Or it might look something like this. Negative 3/5 equals x. Okay, great. The x is all by itself on the right-hand side of the equal sign, and the answer is on the other side, right? So what does it mean to solve an equation? It means to isolate the variable. You're going to get the variable all by itself on one side of the equal sign. And remember, you are finding the value of the variable that will make the equation true. You are finding the value of the variable that will make the equation true, right? That's what's involved. Let's go through and let's talk about some mechanics of solving. So I'm going to put here little b, when solving. When solving. All right, and I'm going to put an example up here to write. You don't need to copy this example. I just want you to see it as I'm going through so you have something to look at. All right, so here's an example of an equation that is solved. Okay, so I want you to notice a couple things. Number one, do the work, and I've been harping on you about this with you guys on all of our stuff. Do the work, and I'm going to go to red, below. Do the work below. Notice this step is below, and this step is below that, and this step is below that, and the solution is below that, right? Do the work below. Work down. Do the work below. Very, very, very important when solving equations. Number two, use, and then I'm going to go to green here, only one equal sign per line. Use only one equal sign per line. This is going to help you out. Notice the original equation has one equal sign, the left side and the right side. One equal sign, the left side and the right side. One equal sign, left side and the right side. One equal sign, left side and a right side. It is really, really important that you use only one equal sign per line. And again, this results in a left side and a right side. These are the little things that make you good at math. These little things. Look, let me let you in on a secret. You know what happens a lot of time in solving the equations? Students know what to do, but you know what happens? They make mistakes. They know what to do, they make mistakes. And you make more mistakes when you don't follow good procedure. When you don't follow good procedure, you're more apt to make more mistakes. So look what I just did. See how I have my equal sign almost in a row there? All right, this was freehand, so you know it's not perfectly in line, but it's basically in the same place. And I have a left side, and I have a right side. And that's what your equation should always have. And the key about an equation is the left side always equals the right side. Left side always equals the right side. And so number three, last one here in this idea, solutions can be checked by placing their value back into the original equation. Solutions can be checked by placing their value. Solutions can be checked by placing their value back into the original equation. Back into the original equation. Solutions can be checked by placing their value back into the original equation. Solutions can be checked by placing their value back into the original equation. Isn't that what I did right here? Right? We said the solution was 18, and what did I do? I took that value, 18, and put it back into the original equation to see if I'd get two things that were true, or a statement that was true, and I did. Therefore, that's how you would check. All right, if you think you solve it and you get x equal 18, put 18 back in for the variable and see if you get a true statement. If you do, then you know you're correct. You're positive, you're correct, and you're in good shape. Now, let me remind you of something. When taking a test or a quiz, when do you do this check? When? All right, you don't need to write that. I'm just talking to you here. When do you do this check? Hey, you do this check after you finish the whole quiz or the whole test. If you stop after each problem and try to do the check, you may run out of time to complete the quiz or complete the test. Remember, you're to do everything first, and then you're to go back and check. All right, checking is done with time that is remaining in the time for the quiz or the test. That's just good test-taking principles, and so be careful there. All right, number three. So then the question arises, how do you isolate the variable? If solving means to isolate the variable, how do you isolate the variable? How do you isolate the variable? Logical question. Very important aspect. Now, my philosophy in teaching mathematics is, and you don't need to write this, less is best. That's my philosophy in teaching mathematics. Less is best. Instead of teaching you 4 things, if I can teach you 2, 4, instead I teach you 2, that's better. You only have 2 to remember, not 4, right? This is my principle. And so there are things that you can do that we can reduce the amount of things you have to remember. And that's why I teach this aspect of solving equations this way. All right, that's why I teach this aspect of solving equations this way. Because if we'll solve equations in this manner, then it will be best. Okay, so how do you isolate the variable? Well, let me show you an example here. A. What are you going to do? You're going to move all numbers on the same side as the variable to the other side. Move all numbers on the same side as the variable. Move all numbers on the same side as the variable. Move all numbers on the same side as the variable to the other side. Move all numbers on the same side as the variable to the other side. Let me show you what I mean. I'm going to use a little color here. I'm going to use a green 7, and then a blue X, and then I'm going to go a red -3, and then I'm going to finish off in blue equals 12. All right, if you notice, here's my variable right there, the X. We've got a left side, and we've got a right side. So what do I have to do? I have to move 2 things. I've got to move this 7 from the left side to the right side, and I also have to move this -3 from the left side to the right side. Once I move the 7 and I move the -3, the X, the variable, will be all by itself on the left-hand side of the equal sign. So that's what we're doing when we're solving an equation. Now we're going to start with easy equations, and then we're going to build as we go to something a little bit more interesting and a little bit more challenging. So, little b. All right, hang in there. We got to do a little bit of words here in the beginning before we start understanding the principle. And this is very important, so I need to lay a very firm foundation here. B, things, and I'm going to go in red here, added. Things added. Back to blue. All right, so here we go. Things added to the variable are moved by. Added to the variable are moved by. Things added to the variable are moved by. All right, grab your red again. This makes it very, very easy. Things added to the variable are moved by adding. All right, what could be easier? Something's added to the variable, we're moved by adding. And what do? We need blue for one word here. Things added to the variable are moved by adding, and we'll keep going in red here, their opposite. Their opposite. and then we'll finish off in red to both sides. So things added to the variable are moved by adding their opposite to both sides. We really have a property that allows us to do this, and this is called the addition property of equality. The addition property of equality. The addition property of equality. And it goes like this. If A equals B. Okay, so we have an equation. We have a left side that equals a right side. Then you have the right to do this. On the same side as the A, add a C. Right? Now we have our equal sign, and on the same side as the B, add the same C. We end up with a true statement. If A equals B, then AC equals BC. And of course, look, this is true, and of course it would be. If we had something like this, I went blue there. Let's suppose we had something like this. Let's suppose A is 2 squared and B is 4. And by the way, doesn't 2 squared equal 4? It does. If we add the same quantity to both sides, we still have a true left side equal to the right side. Now the left side equals 9 and the right side equals 9. It's still an equality. The things are still equal. That's why it's called the addition property of equality. Well, what's it saying? It's basically saying this. We can add the same quantity to both sides of an equal sign. We can add the same quantity to both sides of the equal sign. And that's what we're doing. Things added to the variable are moved by adding their opposite to both sides. So let me show you what I mean by this. Things added to the variable are moved by adding their opposite to both sides. So C. Let's identify what is added to the variable. Identify what's, then I'm going to go to red, added to the variable. So I'm going to show you some equations. And I want us to just simply figure out what is added to the variable. Now this will always be on the same side as the variable. So I'm going to go through a progression here of some looks. So number 1, let's suppose we had this. X plus 7 equals 15. Now remember, we want to isolate the variable. So what is added to the variable? Well, the 7 is. The 7 is answer. The 7 is added to the variable. And we'll want to move that 7 to the other side by adding its opposite to both sides. We'll do that in a minute. We're not going to do that right now. We're just trying to figure out what's added to the variable. How about something like this? Y minus 3 equals 12. What is added to the variable? Well, I hope you'll say the answer is negative 3. You say, wait a minute, I don't see that. Can I refresh your memory? Do you remember that this is the exact same thing? Right? Aren't those the same? We talked about this in the beginning of the school year, right? That y plus a negative 3 or a number minus 3 is the same as that number plus minus that number. So isn't a negative 3 added to the variable of the y? Sure it is. Sure it is. And we would move that negative 3 by adding its opposite to both sides. How about this one? How about this? How about negative 9 equals n plus 4? Negative 9 equals n plus 4. Now be careful. Don't always look on the left. Where's our variable right now? It's over here on the right. So what's the thing added to the variable? And I hope you say it's the 4, right? That's what's added to the variable, and we'll want to move the 4 by adding its opposite to both sides. Okay. Number 4. How about this one? 2a plus 1 equals 7. What is the quantity or the thing added to the variable? I hope you say the 1. Here's our variable, and it's the 1 that's added to it. What's this 2 doing? Is the 2 added to the variable? Well, what's the name for that 2? That 2 is a coefficient, isn't it? And what does a coefficient do to the variable? It, hopefully you're thinking multiplies, right? So the 2 isn't added to the variable. The 2's multiplied times the variable. We'll learn what to do with those next lesson. Right now we're just worried about what's added. And it's the 1 that is added to the variable, right? It's the 1 that is added to the variable. So again, I'm trying to give you a progression and show you all the possibilities. I mean, how about something like this? How about this? How about 3/5 plus n equals 11? 3/5 plus n equals 11. What's the thing added to the variable? I hope you'll think the 3/5, right? Commutative property, you can think of that if you need to. But it's this 3/5 that's added to the variable, and that's what we need to move by adding its opposite to both sides. By adding its opposite to both sides. Here's an odd one. This will be our last one, and then we're going to actually get to it. Okay, and then we're going to actually get to it. Let's suppose we have something like this. -4 plus 9 equals -3 minus 2n. Now look, what we're looking to move is always on the same side as the variable. Because remember, we're trying to get the n all by itself on its side of the equal sign. What's the -2? It's a multiplier of the n, right? We're trying to find what's added to the n, and it's a -3. And it's the -3 that we would move, all right? Moving things added to the variable. All right, we're going to do very simplistic equations. Remember the principle that I keep trying to tell you. We're going to learn procedure on easy things. Don't throw a monkey wrench into it by thinking, oh, it's so easy. I'll just, it'll be a piece of cake and I'll just do it. No, 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 no. We need to be careful here. All right. So remember, things added to the variable are added by moving their opposite, also called the inverse, to both sides of the equal sign. All right, so D examples. So let's go ahead and do some problems. Examples. Number 1, let's suppose we had this. N minus 3 equals 12. Okay, so off to the right, we have to figure out what is added to the variable. So I'm just going to write what's added. So again, you're looking on the same side as the variable, and you're looking for the thing added. And hopefully, you would say the -3. So remember now, we must add its opposite or its inverse. What's the inverse of -3, or what's the opposite of -3? The answer is +3. So let's add +3 to both sides. I'm just trying to show you on the side here what we're thinking. This is really what should be going on in your head, right? The stuff on the right should be what you should be thinking, but we're writing it down now, so we'll go back and look at our notes and remember what we were thinking. All right, so here's my equal sign, right? I have a left side and I have a right side. Most students prefer the vertical method. To the left side of the equal sign, I'm going to add a +3, right? The opposite of -3. And whatever I do to the left side, I have to do the exact same thing to the right side. Now, some students like to draw a line, and you can if you want. But look what we get, n, and look what happens here. That's a 0. That's how things move that are added to the variable, by getting the add up to 0. Equals, and on the right side, hopefully you think we have 15. So really, what's n plus 0? It's n, and we end up with a solution of n equals 15. And by the way, this was a simple equation. Doesn't it make sense when n's 15 that the equation is true? Sure. But we solved it mathematically. And remember, we're learning on simple things the procedures to do on more complicated things. And I'll give you a hint. Almost every equation finishes with this step. You hear that? Almost every equation finishes with this kind of a step of adding the opposite to both sides, or at least gets close to finishing with that step. Let's do another example. Number two. How about this one? 5 plus y equals negative 21. 5 plus y equals negative 21. All right, what do we want to move? We want to move the positive 5, right? The thing on the same side as variable. How are we going to do it? We're going to add negative 5 to both sides. Doing b dot s dot for both sides. Again, this is what we're thinking. This is what you should be thinking. So again, here's my equal sign. Now again, I usually don't have these dotted lines on my paper. I'm just doing this for your sake. Right? And I'm going to add a negative 5 to the left side of the equal sign and a negative 5 to the right side of the equal sign. Again, if you like drawing a line, draw the line. Now, please make sure that this equals 0. We're usually not going to write that because it's boring. But make sure that that's 0. If it is, you did the right thing. If it's not 0, you made a mistake. That leaves us to y equals, okay class, look over here. What happens when you add those up? All right, you'd be thinking. All right, got an answer? What happens when you add those? All right, I hope you're thinking that 21 negatives and 5 more negatives gives you 26 negatives, right? And the answer is y equals negative 26. Y equals negative 26. Okay, let's do another one. A few more and we're done. A few more and we're done. Number 3. How about this one? 9 equals x plus 13. 9 equals x plus 13. What do you want to move? What do you want to move? I hope you said move the 13. How do you move it? Add its opposite to both sides. What's the opposite of positive 13? Negative 13, right? So we add negative 13 to both sides. So I'm going to go to the right-hand side of my equal sign. I usually put it underneath the number I'm moving. And that's where I start, right? Do you guys notice what I just did? I started on the right side. Why? Because it's this positive 13 that I'm moving. That's why I started on the right side. And it's why I'm using a negative 13 to both sides. So I started on the right side because that's the thing I'm trying to move. That's the thing. These two better add up to 0, right? That's what I'm trying to do. So that's where I started. That's important. It's a little thing, but it's important that I started on the right-hand side. And now I'm going to go to the left-hand side of the equal sign and put a negative 13 on that side. Now, what does the right-hand side become? This should be blue. So I got my equal sign, right? My right side is x, and again, this is 0, right? It better be. All right, now the solution will be on the left. So what do you get, class, when you add up two numbers on the left? All right, I hope you think negative 4, 9 positives and 13 negatives. All right, remember, the 9 positives wipe out 9 of the 13 negatives, and there's 4 negatives left. That's what's going on. How can you do it quickly? Start at 9, count to 13, that's 4. And there's more negatives than positives, so it's got to be negative 4, right? Either way you're thinking of it, it's negative 4 equals x, and that is the solution. Now again, you can go through and you can do a check. Right, number 4. Okay, so what if they throw something like this at you? Q plus parentheses a negative 3 equals a negative 20. Okay, that's no big deal. Which side is your variable, on the left or the right? It's on the left. Well, I got to get everything from the left side to the right side. So what do I want to move? What do you want to move? I hope you said the negative 3, right? How are you going to do it? Add its opposite. Add positive 3 to both sides, right? So where's the number I'm moving? It's on the left, so I'm going to go under it on the left, and I'm going to add a positive 3. I have to go on the other side of the equal sign now and add the same thing, a positive 3. What does my right side look like? All right, I got the Q. This better be 0, and it is. And what do you get on the right, class? What do you get on the right? I hope you say negative 17, right? 20 negatives and 3 positives. 3 of these positives wipe out 3 of the negatives. How many negatives are left? 17. Or start at 3, count up to 20, 17, and what are left? The one with the most, and that's negatives, negative 17, and that's our answer. Q equals negative 17. All right, I got to show you a couple word problems, and we'll be done for today. A couple word problems, and we will be done for today. All right, just went back and looked at my lesson plan, and that's where I want to stop for today. And so we're simply solving equations by isolating the variable, right? What does that mean? Get the variable all by itself on one side of the equal sign. Let me refresh your memory real quickly before we finish up. What does it mean to solve an equation? We're trying to find the variable, the value of the variable that makes the equation true, right? Solving means find the value of the variable that makes the equation true, and that's what we're doing. What are some things we want to do in solving, right? We want to isolate the variable, get it all by itself on one side of the equal sign. Some things that will help us, remember, do the work below. Only use one equal sign per line. Have a left side, have a right side, right? And solutions can be checked by placing the value back into the original equation. Again, that's when you're done and you have time. It's when you're done and you have time. How do you isolate the variable? Move all numbers on the same side as the variable to the other side. Right? How is that done? Well, things added are moved by applying the addition property of equality, meaning you add their opposite, also called the inverse, to both sides of the equal sign. I showed the things that we were going to move and what was added, and here we started moving it, right? And so we moved the same things on the same side as the variable to the other side, and that finishes up our lesson. Okay, have a great night, and we'll give you homework in class on Monday and be able to help you out in class. Hope you enjoy the weekend.